Okay, we're in section 42. Again, the sections are going to have contents, examples, exercises. My name is Ron Bannon. This is my version of Webster Wells' Advanced Course in Algebra, which goes back to 1904. This is the document that you're looking at now is a document that's being prepared for the Prison Mathematics Project. All right, my name is Bannon. My email address is also Bannon. That's B as in boy, the @ symbol, NNON.US. All right, so let's look through this. And again, each section that comes along, you may wonder what's the deal here. We go forward. We're going to look what the deal is. All right, so the deal about this one over here is they're going to be inequalities. What we'd like you to do is we certainly want you to read through inequalities. Now, certainly the way it's been treated in this text, you might be confused by it. I'm not sure. But again, read it. I really do mean read through that. And Wells is, quite thorough in his treatment of it. The bottom line, though, we'll go through examples. As I do that, my goal is to do it the way I would like to teach it. But again, if you're looking at these things and saying, I want to do it differently, you can. So I'm going to, when I do these problems over here, I'm going to talk about, basically, I'm going to be concentrating in two properties. And let me just write this down for you. One property I'm going to use, if A is less than B, one thing you could do is you could add anything to both sides of this inequality, and it'll still maintain its order. That's one really important fact that we're going to be using over and over again, that we can give or take from a side without affecting inequality. The other one I'm going to be using, and let me just erase this now, is something that's a bit tricky. So if A is less than B and C is greater than 0, I can say that AC will still remain less than BC. That's provided C is greater than 0. However, if C is less than 0, and again, it's also explained in Wells's text, AC would be greater than BC. And again, that's two of the facts that I've gleaned from reading through Wells's work. Let me erase this. Again, what's incumbent upon you is that you've actually read Wells's work, and you're going to see me using these two big properties here. All right, let's take a look at the first one. And the first one I'm looking at, the first thing I'd like to do is get across to you that fractions for some students are very difficult. So I'm going to say the LCD. The LCD for this problem is 3, and 3 is a positive number. All right, so what I'm going to do, I'm going to multiply both sides by 3. It'll have no effect on inequality, by the way. Let's put that down for you. What do you get? 21x minus 23, 2x plus 15. The next thing I want to do is I want to take 2x from both sides. Now remember what I said, if you're taking or giving to the sides, no effect on inequality again, which is good news. I'm going to add 23 to both sides. What do you get here? We get 19x. And let's see what you get there. You get, let's see, 38, right? Now what I'm going to do, I'm going to multiply both sides by 1/19 or divide both sides by 1/19. I want to point out that 1/19 is a positive number. All right, so if you multiply both sides by 1/19, it has no effect on inequality. And what are you going to get here? X, and 1/19 times 38 is going to be 2. So what do I know? I know that x is less than 2. Nowadays, we like to visualize that, and there's a reason for that. We're going to put a number line down. On the number line, we're going to put the number 2. And we put a circle on to indicate we're interested in the number 2. And what's x? It's all those numbers, which is an infinite set of numbers, that's less than 2. We also write an interval down. The interval is going to be written down as minus infinity to 2. All right? This is what Wells is going towards, writing it down. When you get it there, read the inequality from the letter x. That says x less than 2. All right, this one's a little more interesting to me, and I'll tell you why. Looking at it, I'm seeing something here, and what they're telling me is they're telling me something to be, find the limits of x and y in the problem, and it doesn't look easy. All right, but I got to point out to you that it really is properties of inequalities. all right? And what I'm going to be doing over here, I'm looking at it, and I certainly would like to eliminate in the problem something. And I'm going to concentrate again on equality. So I'm going to say 33 is identical to 2x plus 3y. But what I'd like to do is I'd like to use that to eliminate either the x or the y in the problem. And the way I'm going to do it, I'm going to focus in on something. So for example, if you focus in on this, right, I want to focus on the x, and I want to make them opposite. Now my gut feeling here is I want to multiply the inequality by a positive number. All right, now what's the LCM between 3 and 2 is 6. So I'm going to multiply the top equation by 2. Whoops, that's not an equation, equality. So when you multiply an inequality by 2, it's a positive number, it'll have no effect on that inequality. Let's write that down. What do you get? 6x plus 4y is still going to be greater than, well, 2 times 37 is 60, and 14, 74. I am going to multiply the bottom equation by minus 3. This has no effect on inequality, by the way. So what do you get over here? Minus 6x minus 9y equals minus 99. A little line over here. And I want to remind you what we're doing. We're going to be adding the same thing to both sides of the inequality. Now when I say that, we're going to add this to the left side and this to the right side. It'll have no effect on that inequality. What are you going to get over here? Minus 5y is greater than, let's see, what's minus 99 and 74? Let's see what that would give you. What would that give you? That's going to be what? You're going to get 25, right? It's minus 25. Now what I got to do is, I'm looking at this thing over here and I'm saying to myself, you know what, I could solve that by multiplying both sides by minus 1/5. Now minus 1/5 is less than 0, so it's going to reverse the direction of inequality. What are you going to get? Y greater than 5. That's the limit of the y, by the way. That's done. We know what y is. So if I want to know what the y's are greater than 5. Let me put a graph down for you. This is 5. Y is greater than 5, which is over here. As an interval, this would look like 5 off to infinity. All right? Now let's do the x's. I'm going to erase this business here. I'm done with that. And I'm going to get the next thing. And what I want to do now, I want to eliminate the y. So I'm looking at, between 2 and 3, and lo and behold, it's 6 again. That's the LCM. So I'm going to multiply the top thing by a positive number. Again, please try to pick with positive numbers if you can for inequality. The bottom one I'm going to multiply by minus 2. Let's put that down over here. What do you get? 9x plus 6y. Remember, if you multiply by a positive number, it has no effect on inequality. Well, it's going to be 90 and 21, which is 111. Minus 4x minus 6y equals, and again, multiplying equality by numbers, no effect on inequality. What do you get? Minus 66. I'm going to add those together. I'll put it over here. And what do you get? You would get 13x. Again, let me point out what I'm doing. I'm adding this to the left side, that's the right side, and they're equal. It'll have no effect on inequality. The y's disappear. And what do you get here? Well, let's see what you get. 34, 35, 45. Did I say that right? Make sure I did that right. 34, 35, 45, yeah. All right, let's say if I did a mistake there. Someone said, why do you think you made a mistake? I'm just looking at the number. I don't like the number. That's why I'm saying it's a mistake. I'm not saying it is a mistake. I just don't like that number. Let's see if I did that right. 3 times 3x is 9x. 3 times 2y is 6y. 3 times 37 is, let's see, 90 and 21, 111. Minus 4. Oh, I see it now. I see it. I made a mistake. And someone says, how could you know you made a mistake? I just didn't like the number. Maybe I didn't make a mistake. I didn't like the number. Let me write this as a mistake. I'm glad I make mistakes sometimes. I said minus 2, right? That's minus 4x minus 6y equals minus 66. A little line over there. I want to remind you what we're doing. We're adding this and this, which are equal to that inequality. And what do you get? Well, let's write this down now. You get 5x. The y's disappear. And again, I can add anything I want to the inequality. It's not going to affect it. And 111 minus 66 is 45 again. I like this number better, by the way. I'm not saying it's right, by the way. Make mistakes, though. What's this going to be? X greater than 9. I want to put the number line down for you. And if x is greater than 9, it's over here somewhere. What's the interval for that for x? It would start at 9 and go off to infinity. Again, Wells is just looking for this part here. Let's look at the k, see how we did. And I got the y, and the y is this over here. I definitely see that. Let's see if they got the x. And what did they say the x is? You know what? I think I made another mistake. And either my key is wrong or I am wrong. Let me see what happened over here. Yeah, this is an error. Error. This is an error. I'll correct it. When you're looking at the PDF, you will not see that. It'll be in the video, though, but you're not going to see it in the PDF. I will correct that. All right? Let me go to the next question. And next one, it's quadratic inequality. This is more difficult to do. And I want to tell you, the way we're going to do these things is we're going to compare it to 0 first. And the reason for that is we have rules about it, and we'll go through this one stage at a time. All right? So I'm going to write this down. X squared minus 4x minus 21 is going to be less than 0. The next thing I'm doing is going to factor it. X, 7, 3, minus, plus. Let's check it out. You get x squared. You would get minus 4x and get minus 21. The next thing, I'm going to put the number line down. You're going to put the zeros down. The zeros of the first the 0 of the first factor would be minus 3. You know, so I'm putting a number line down. There's two numbers. The 0 of the second factor would be 7. All right? So what are you doing over here? Well, you got to get some comparisons here. And the comparisons, what's nice about this, if you got it written as a product, I'm really boiling the product down as when is it positive, when is it negative, and that's all we're basically doing. I know where it's 0. It's 0 here, and it's 0 here. Everywhere else has got to be positive or negative. So what I'm going to do over here is talk about sign analysis. So for example, a good test point over here, and you can pick any number you want after 7, I'm going to say 8. If you plug 8 into the first factor, 8 plus 3 is 11, which is a positive number. If you plug 8 into the second factor, it would be 1, which is a positive number. Well, a positive number times a positive number gives you a positive result. Any number you pick in that interval would turn out to be positive. Now let's pick a test point over here. I'm going to say between minus 3 and 7, a good test point there would be 0. Plug it in. What do you get? Positive. Well, let's see. What do you get? When I say positive, 0 plus 3 is a positive number. And you get a negative number now, because 0 minus 7 is negative. That, as a product, would be negative. Any number you pick between minus 3 and 7 would result in a negative number in the product. Let's pick a number below minus 3. I'm going to say minus 4. You could pick any number you like below minus 3. Plug it in. Minus 4 plus 3 is a negative 1, so it's a negative number. Minus 4 minus 7 is minus 11. That's a negative number. And a negative number times a negative number is a positive number. All right. Someone says, what are you doing now? You must answer the question. What's the question? When is it less than 0? It is only less than 0 when it's negative. So where's the x? I'll write this down for you. The x is between minus 3 and 7. As an interval, which I prefer to write down, it starts at minus 3 and it goes up to 7. All right? This is the way Wells would write his answer down now. All right, let's go to the next one. A little more difficult. And you know what I mean by that? It is more difficult. All right? It is more difficult. And the reason for that is very abstract. It's super abstract. So what I'm going to do over here is look at it. It says prove that if A and B are positive numbers. So what they're telling me now, they're telling me that A and B are both positive. This makes my life a lot easier. I'll tell you why. I can just simply multiply both sides by that number, which is AB. Now, to show that this is true, what I'm going to show is I'll show this instead. I'll show that A over B plus B over A would be greater than or equal to 2. I want to show that. All right, by showing that, I'm showing this over here. Okay, well, what am I going to do? I guess I'll multiply both sides by AB. Am I allowed to do that? I certainly am. And the number one reason I can do that is it's a positive number. So if A is greater than 0, B is greater than 0, A times B is greater than 0. So I'm going to multiply both sides of the equation by AB. What would I get? I would get A squared plus, let's see what would you get there, B squared greater than or equal to 2AB. Let me go to the next step. Well, I like that 0. I'm going to put that down for you. I don't know if that's going to help me out, but I'll write it down for you. It might be different in my work over here, but that doesn't matter to me. A squared minus 2AB plus B squared greater or equal to 0. Let me see if I can factor that. That would be A minus B squared greater than or equal to 0. Well, what I notice about this over here, and again, I can't say this enough times, that A and B are greater than 0. Right? That's all I know about that. So all I'm going to say over here is I hope you can realize no matter what I do here, this thing will always be, when I square it, a non-negative number. So I hope you can agree, if it's a non-negative number, it'll always be greater than or equal to 0 if it's a non-negative number. Now someone says, how do you know it's non-negative? I'm squaring it. And even if A were equal to B, right, what would I get? 0. 0 squared is greater than or equal to 0. So that's sufficient. I'm going to hope that's sufficient. Now someone could say, I'm looking at this work instead. Can I do that? Of course you can. You can do that work, all right? And it just looks a little bit different. And again, your mileage may vary, saying, I'll do it this way or that way. And again, let me look at this one over here. It's really the same type of story. It says prove that if A and B are unequal. So now all I know is that A is not equal to B. That's all I know. So my question over here, what would you do? Well, I'm going to say I'm still going to do that 0 business because it makes it easy for me to do that. So let me write this over here. A cubed plus B cubed minus A squared B minus AB squared is greater than 0. All right, now someone says, what are you going to do now? Well, I guess I'll look at it and try to figure something out here. And let's take a look. And again, if it's a dead end, I can always try again. And that's what's nice about these problems, a dead end. You'll know you got a dead end after a while. And let's take a look at this and see what I could do. I guess I could try to factor, right? But let me put this down over here. I'm going to put down A cubed minus A squared B plus B cubed minus AB squared greater than 0. Let me keep going. I'm going to factor out an A squared. And what are you going to get there? Let's see, you'd get A minus B, right? What do you get over here? I'd factor out a B squared. And don't be intimidated. If you dead end, you dead end. This would be B minus A greater than 0. I'm starting to see something now. Let me continue to write it down. I'm going to write A squared, A minus B. I'm going to put down minus B squared, and this would become A minus B. Again, it might be different than the work that's in the blue area. That doesn't matter. What do you get over here? I'm going to factor this now. A minus B. And what do you get there? A squared minus B squared greater than 0. Let's keep moving. A minus B. And what does this give me? This gives me A minus B, A plus B greater than 0. All right? Let's continue to write this down. And what do you get over here? A minus B squared A plus B. All right? So it says prove they're unequal. Oh, they said something else. I missed that. That A and B are greater than 0. All right, how do I know that? They said they're positive numbers. Well, if they're unequal, again, I want to point out over here, they're unequal. This could never be 0 if they're unequal. And I don't care if B is bigger than A or A is bigger than B. When I square that, this thing will be always greater than 0. This is always greater than 0. What does that mean? It's positive. Whoops, I made a mistake in writing that down. Let me get my eraser out. That this thing here, let me write this down for you, that A, whoops, I keep doing that. That this thing here, A minus B squared, is always greater than 0. I know that much, all right? So what do I know about this? It's a positive number. So whatever is a positive number, I'm not too worried about that. You know, it's a positive number. You know, I'm going to say I could represent it by K greater than 0. It's a positive number. What could I do? I could actually divide both sides by that now. And I'm going to write that down for you now. Let me erase this out. And it's really important you know what I'm talking about over here. That A minus B, since A is not equal to B, but A minus B could be negative or positive, but I'm squaring, it's always positive. So I'm going to multiply both sides by this. Let me write this down for you. And what would I get? I'd get this. A plus B is greater than 0. All right, let's go back and make sure we understand what we're talking about over here. It says prove that if A and B are unequal positive numbers, that this is true. Well, what did I do? I wrote this down and I followed a path. I'm right here now. Now again, I want to repeat this. What do they tell me? A and B are better than 0. So what does this mean? It's got to be greater than 0. If A and B are greater than 0, A plus B is greater than 0. All right? Both of those numbers greater than 0. We're done. We're good. All right? Let's keep moving. All right, another proof problem. All right, another proof problem. So one thing you can do in proof problems is you can get stuck sometimes. And what I want to claim, when you're getting stuck, it may not be a bad idea to read what somebody else has written down. Now, someone's going to say, well, you know, I was stuck on these too. Maybe I shouldn't really follow what you said in the words. I should have just studied your answer key. And you could, but I'll be honest with you, it can't hurt to listen to what I said about it. But again, I want to repeat this. You probably should be looking at the answer key too. All right? Now, over here, I want to be honest with you. A lot of students are going to bog down in this one. All right? So what I'm going to claim over here is I'm looking at it. Again, what I'm looking at over here is this over here. And I want to maintain that I know something. I know A, B, and C, they're unequal positive numbers. So what do I know? I know A is a positive number, B is a positive number, and C is a positive number, and none of those are equal to each other. They're different numbers. They're different positive numbers. So what did I do? I basically wrote down that we had some prior examples that we did, right? So I want to point out what I mean by that. I'm using something from the past. Someone says, I have no idea what you're talking about. We're using this. It's from the past. Let's make sure you know what that means. A cubed plus B cubed, A squared B. That's all I'm writing down, AB squared. We've already shown this to be true. We can use that again and again. That's a nice thing to know. And I'll be honest with you, if you know that, you can basically substitute letters. So what am I doing over here? I'm basically just substituting. Now A becomes B, B becomes C. Right? You see that? So I got B cubed, C cubed. I'm just copying the formula. What formula are we using? We're using this formula over here. So I get B squared C plus BC squared. This one's done. I got this one covered. This one, we're just copying the formula. That's all we're doing. What am I doing? I'm replacing B with C. That's all I'm doing. I get this over here. Then what did I do? I add those three together. You can add inequalities together with any effect whatsoever. Let me write that down for you. So if you did that, what do you get? I'm going to write this down. You'd get 2A cubed. I want to point out where that's coming from right here. You would get 2B cubed. You would get 2C cubed. greater than, this is going to be a tough one. I'll have to write it down for you. So let's see. I'm going to look for a squared b. I'm seeing this over here. Do I see any other a squared b? I do not. I'll write this over here. A squared b. Then I'm going to look for ab squared. I'll write that down. Plus ab squared. I got to jam this in there. What's the next thing I see? B squared c. B squared c. Next thing, I see bc squared. The next thing, I see this. A squared c. Last but not least, I see this, which is ac squared. What do I see? Let's clean it up. On the left side, I see 2 times a cubed, plus b cubed, plus c cubed is greater than, I'm just going to write down this side now. What do you get? A squared b plus ab squared plus b squared c plus bc squared, I'm running out of room, plus a squared c plus ac squared. So I use something from the past to show that this is true. I want to show you what I mean by that. I got this. I see that. Did I get this? Yes. Did I get this? Yes. Did I get this? Yes. Did I get this one? Yes. Did I get this one? Yes. Did I get this one? Yes. So here's the problem. If you didn't do number 5, number 6 may have proved to be really tough to do. All right? Really tough to do. All right, what do you have to do now? Exercise. Exercise. You got to exercise. All right? By the way, this is something that Wells does. He says find the limits of x. That would confuse a modern student. Basically what you're doing is you're solving for x. Relatively simple problem. All right? I did put some work down over here. I write the solutions down for you, and I also use the interval notation. Again, you may be confused by some of this. What you're trying to do, you're trying to aim towards the answer. Let me point out, this is the answer over here. We're hoping you're looking at this, though, as being a legitimate answer, too, at some point. Number 2 looks relatively simple. Again, I put the answer over here for you. Number 3, relatively simple. I put the answer over here. This is more difficult, and I'll tell you why it's more difficult. It's abstract. A lot of students are seeing this as a very abstract problem, but they're going on, they're saying this thing over here, and when I say this over here, I bet this is going to be useful in the problem. But what are you doing? You're working through the problem. Now, why do they say a minus 2b is positive? Let me write down what I mean by that. They're saying a minus 2b is positive. Probably you're going to either multiply the inequality by that, or divide the inequality by that, all right, at some point. But anyway, go through that, make sure you can do that, and make sure you're looking at that as we do that. I want to point out what I mean by that division. Over here, you see that. This is a positive number. What they did was they multiplied both sides by 1 over a minus 2b. And let me repeat this. If this is a positive number, 1 over a minus 2b is still a positive number. All right? Still a positive number. So they did that, and they get something pretty simple, and they kind of work through it. All right? Now, again, I do want to point out it's really important you read before you attempt to do the problem. All right? Now, granted, I know for a lot of students, could be jump in reasoning, and I want to point out going from here to the next step might cause some confusion. All I can say is, please consider reading it. I really do mean that. Please consider reading that. Next one up, it's still abstract, but they're giving me some information over here. They're telling me that m and n are positive, and that n is greater than m. All right? Go through the work on your own. If you have trouble, look at my work. All right? This one's that limit problem. What are we doing? We're basically doing elimination to do that. Again, answers are listed for you. Another limit problem, what are you doing? You're trying to find out the limits of x and y, which is basically solving an inequality for both x and y. All right, this one over here, it's a limit problem, but there's 2 inequality. All right, there's 2 inequality. All right, if I were doing that, I'd probably line up the inequalities and try to stick with using multiples of positive numbers. Let me point out what I mean by that. If I see this inequality here and this inequality here, I would try to rewrite those so they're in a nice little order for me. And if I did that, I want to point out that this inequality here, probably better off writing it as, I'm going to add 11x to both sides. What would you get? You would get, what would you get? you would get 14x. I'm going to add 11 to both sides, and that would be what? Well, if I did that, you would get, let's see, 24 and 11, that would be 35, right? I like that. Not a bad thing to do. Let's do this one over here. And what do you get over there? Well, I'm going to write this as this way. I know it's difficult. I'm not saying it's easy. Take 5x from both sides, you get 15x. And if you take 3 from both sides, you get 20. Now, could I solve these inequalities? I certainly can. What do you get over here? X. I'm going to multiply both sides by 1/14, it's a positive number. That's 35 fourteenths. Can I solve this inequality? I would divide both sides by 15. It's a positive number, no effect on it. It's like multiplying by 1/15. What would you give there? You would get 20 over 15. I'm going to reduce these numbers. 7 goes into 35 5 times, and it goes into 14 2 times. And over here, this is divisible by 5. You're going to get 4/3. All right, so someone said, yeah, I'm confused by what's happening over here. And there's 2 conditions that need to be met. And I want to write these down for you. There's 2 conditions that need to be met. What are the conditions? One of the conditions is that x must be less than 5/2. All right, now the other question is, if 5/2, maybe I should write that down for you. 5/2 is 2 1/2. Now, if you looked at the other one, which is 4/3, right? That's going to be 1 1/3. Now, if I did that, and I kind of line up the number lines, I'm going to say over here somewhere, right? That's where 4/3 is. And what's the x? The x is actually greater than that number. Now, what I got to get across to you, they did say and. What's and? Both need to be satisfied. What's where it being satisfied right here. Now, someone says, how could you write that down? Well, I'm kind of looking at the picture. I could write that down. I could say x is less than 5/2, and it's greater than 4/3. That's the way Wells would probably write it down. All right? Now, what I want to get across to you, though, is that I also put intervals down for you. Right? But you don't need to put the intervals down. You can write down the way I wrote it over there. I know people get confused by this, but the bottom line is there's 2 conditions that need to be met. This one and this one. Right? There's only one letter in the problem. Where they intersect. This is called a compound or double. Someone says, why is it compound? We read it with the word and. Why is it called double? There's 2 comparisons being made. All right, this one over here is a word problem. I do want to recommend word problems. You should, sorry about that. You should be writing down the equations for these things over here. Relatively, they're simple to write down. Read the thing left to right and try to write down what they said. I'm hoping as you do that, you start to realize they're saying certain things. And then, of course, they say other things. Like, for example, they said they're positive integers. What does that mean? 1, 2, 3, 4, 5, yada, yada, yada. So your answer's got to be a positive integer. And again, you're going to solve an inequality, just like we did in problem number 8. Number 10, very similar. You're going to get equations down over here. Make sure you understand that. They do say, again, they say that these are houses in a certain village. If there's houses, it's got to be a positive integer, and you work through that as well. And the answers are listed for you over here. Again, we want to make sure you know you're looking at answers. And again, if you think there's a mistake in the answers, please let me know that. Farmer has cows. Again, it's an integer problem, right? Integer problems can be maddening, but these are not difficult problems, all right? And again, they give you the answer, 12 cows, right? Again, quadratic inequalities, these are more difficult for students, and I'll tell you why they're more difficult. They try to do something to these that they shouldn't be doing. The bottom line is we're using sign analysis. What does that mean? Please get it equal, or I'm sorry, compared to 0. What I mean by that, x squared, I keep doing that, x squared plus 3x minus 4 less than 0. Then you're going to factor this thing over here. I guess 4 and 1, right? Plus minus. Put the number line down. What goes with the number line? The zeros. That would be minus 4 and 1. And what you're going to do is pick numbers on these 3 separate intervals where you can test them out. For a good number between minus 4 and 1, 0. A number between 1 and infinity, 2. A number below minus 4, minus 5. all you're doing is plugging in for signs. That's all you're doing. For example, on the 0, what would the sign be? Minus times a positive. What's that? It's negative overall. If you plugged in 2, what would you get? Positive times a positive. What does that give your overall positive? If you put minus 5 in, what do you get? You would get a negative times a negative. A negative times a negative, a bunch of positives. All right, what's the question? When is it less than 0? When is it less than 0? When it's negative. So what's the answer? X would be between minus 4 and 1. All right, they put an interval notation, and you should be thinking about that. All right, next one, quadratic, same principle, not going to change. Quadratic, same principle, not going to change. This one's a quadratic, but it's asking a rather peculiar question. Instead of proving that, what you could prove instead is that 9x squared plus 25 is greater than or equal to 30x. It's the same thing. Proving this might be easier than doing this over here. All right, that's up to you, by the way. Same thing. Over here, same story. Proving this is like proving this. By the way, this is also quadratic. All right, same technique for quadratics. This one over here, I think you're catching on the idea. More abstract, no doubt about it. But they do say for any values of A and B, and they put work down here for you. You may have to look at that work. I'm not sure. All right, you don't have to if you don't want to. Again, they're telling me something about A and B. It's more abstract. I put work over here. You have to look at that. All right, abstract. They do tell me that all letters represent unequal positive integers. Keep that in mind, and I did some work for you over there. Same thing for 20. Make sure you think about it. I know it's tough. I put a lot of work down there. Hoping you're going to look at that. 21, put a lot of work down. Hopefully you're going to look at that. 22, a lot of work down. 23. Someone says, tremendous amount of work. It is. You got to get through the work, though. It's a lot of work. Someone says, it's way too many problems. Do your best, right? If you can't get something, you might want to reach out, get help. Get help from your mentors, your teachers, people that are next to you that are interested in the subject area. Get help. All right, now where are we now? We're at this SAGE business. What's SAGE? SAGE is a computer algebra system, or a CAS. It's free. It's open source. Go to this website over here. You can download the software or use the interactive web-based application. What am I doing over here? I'm solving inequality. But I got to be honest with you. Looking at this over here, it's really easy to read the code. The problem for a lot of students is reading the answer. So here's the deal. You really should be able to do this by hand so the answer makes more sense to you. All right? Again, people may need to reach out to me. My email address is Ben, and that's B as in boy, ANNON.US. All right? Again, what am I looking forward to? Well, I'm looking forward to hearing from you, particularly if you have comments about improving the document. All right? That's what we're looking forward to. Comments about improving the document. All right? Thank you for paying attention, and we're going to need to move forward. We're at 42 now. We'll eventually get